Ethereum blockchain. So why do we use smart contracts? So these are the simplest form of achieving decentralization. So if I want to write or deploy something which runs in a decentralized manner, I can do it with the help of a smart contract. A high degree of security, yes, because it's a completely distributed system and transparent system, and this eliminates the need of third-party applications to validate or do certain actions on the network. One more very important advantage of using smart contract is automatic agreement enforcement. So that's how it gets the name smart contracts. So with the help of code, we can actually automate the process of agreements between two parties. So instead of going into a manual agreement, this could be encoded in terms of a program, and that program execution will actually enforce the agreement. The next advantage is it can help turn legal obligations into automated processes. So when there's an agreement between two parties, there are many legal obligations that can be coded into a program, and with the help of which the legalities can be achieved, which in other terms, if you're going for legal works, there's a lot of cost involved. Also, the added advantage of lower transaction cost, because here there's no intervention. You only pay a fees for deploying the contracts on the network. There's no third party intervention. So transaction cost is comparatively less. So because of all these reasons, Ethereum has gained momentum in the industry, and smart contracts as the way of writing the codes. So with this example, we'll try and understand how does a smart contract work. So let's look at a scenario here. So there's an optional contract between the parties, which is written as a code into the blockchain. So the individual who are involved in this contract are anonymous, which means their real identity is not known, but the contract is made through a public ledger. So now, since this contract is made through a public ledger, it would be available for anyone who want to be a part of this agreement. So how does this smart contract actually execute? So in the smart contract code, there will be a trigger event, which is written in the code, or certain conditions which are written in the code. So the trigger event can be anything. It can be an expiration date, or it can be a strike price, or a certain threshold is hit. So when such trigger events are satisfied or met upon, the contract will execute itself according to whatever is the logic written inside that smart contract. So basically smart contracts are present on the decentralized network, but there should be someone who is calling it, and based on certain threshold met or some event happening, the smart contracts would execute the terms which are written in it. So, benefit regulators can use the blockchain to actually understand the activities in the market. That is one way. While they can maintain the privacy of their individuals' positions. So, they do not need to reveal the identity. They can use this to just look at the market. So, this is one such real world example which can help you understand why smart contracts are important. Now, moving forward to the life cycle of smart contract development. So, like any high level programming language, the Solidity code. So, Solidity is the programming language we are going to study in this unit. The Solidity code is compiled, and after compilation, it generates an ABI code, which is application binary interface, or you can simply call it as a bytecode. So, this is a usual way in which a high level programming language compiles and then debugs and then executes. So, here the steps would differ a little. So, there'll be a Solidity code which you will compile in order to understand if there are any bugs or errors in it. If once it is successfully compiled, it will generate the ABI or the bytecode. Then it is deployed. So the meaning of deploying a smart contract is actually making it available onto the network. So when you are deploying a smart contract, you have to use addresses. Okay. So we are going to understand what are these addresses, how do we get these addresses and everything. But you have to remember that to deploy a smart contract, you need to have an address. What is this address? This address is a Ethereum address. Okay. So we have studied about Bitcoin addresses and Ethereum addresses in the previous unit. So these are hexadecimal representations which start with 0x. 0x indicates that these are hexadecimal representations. So the addresses are always represented in such form. So the contract would be deployed onto the network using a particular address, which is the Ethereum address. Once the contract is deployed onto the network, so now the contract is present on the blockchain network and anyone on the network can interact with this smart contract using functions and events. Okay, so the way we used to give inputs to our code and then look at what is the output, the same way we are going to do it with the help of smart contracts. So what we need to remember is uh, the Solidity code is compiled to a bytecode, and then that bytecode is deployed to the network of nodes, basically all the nodes which are running the Ethereum blockchain. Once the code is deployed, it can be interacted by calling functions using the contract's address. Okay, so we are going to look at all of these things in practical, but first we understand what is the sequence. So coming to a more detailed understanding of smart contract development. So the first step is creating the Solidity smart contract, for which we are going to use the remix IDE. So the extension for the Solidity files is .sol. Okay. So this .sol file is passed to the Solidity compiler, which is going to compile this code for any compiler level errors. So once it is compiled, using the bytecode, it invokes the deployment via Web3.js. So now the smart contract, once it is deployed, you can interact with the smart contract from a front end as well. Okay, so if you look at the bird's eye perspective, there would be a front end, which could be a website written in as simple as HTML, the front end. Then at the back end, the data getting stored on the blockchain, and the intermediation of front end and back end would be provided with smart contract. So once you deploy it, okay, it can be deployed on a private Ethereum blockchain node. So once it is deployed, the network returns the contract address and the ABI code. Okay. And this ABI and the contract address gets stored. So once you pass the address or the ABI code, it instantiates the contract, or it actually launches the contract. Then passing all the parameters for the contract method. So once you have deployed the contract onto the network, you can interact with all the functions that you have written in the contract with the help of parameter passing. And then you can invoke the contract methods for data storage. So once you start interacting with the smart contracts, the interacted parameters or the changed function values would be done, and those results would be stored again into the blockchain node. So in order to perform any operation onto the blockchain, we need to pay a fees which is called as a gas fees, which we have discussed into the concepts we were talking about in unit 3. So Once someone is calling a contract, they have to pass ethers or pay the gas fees to perform the operations. Since the code is present on a decentralized network, everyone who is going to use the code has to pay gas fees, okay, which is in terms of ethers because we are talking about Ethereum blockchain. So this is the overall smart contract development life cycle, which starts with writing your Solidity smart contract, then is compiling it. Once it is compiled, you deploy it onto the blockchain network. Once it is deployed, the contract gets an address, okay, and an ABI code. So this ABI, with the help of this ABI code, you can connect the smart contract to some front-end applications. And then using the front-end application or directly the smart contract, you can start interacting with the smart contract, running the functions, getting the values. And to perform all these things, you need to pay ethers, right? So this is the entire smart contract development life cycle. Next, we are going to start with Solidity as a programming language. We have studied up to this point that smart contracts are the backbone of Ethereum blockchain, which helps you develop your own applications or use case on top of blockchain. So in order to do that, we are going to learn Solidity as a programming language. So let's look at some basics or introduction to Solidity. So Solidity is an Ethereum smart contract programming language. It is a statistically typed language, which means that you have to declare the data types in advance. It is an object-oriented and a high-level programming language. So when I say it's an object-oriented programming language, it is going to follow all the principles of object-oriented languages that you have studied in C++ or Java, which is inheritance, polymorphism, then is writing functions, calling the data members through functions. So all these concepts we are going to study in Solidity, but the syntaxes and the way of writing the code would be different. So the syntax of Solidity resembles a lot to JavaScript, and it is designed to enhance the Ethereum virtual machine. So we were studying about Ethereum virtual machine in Unit 3. What is EVM? So Ethereum virtual machine is the platform which gives you all the dependencies at one place through which you can write your smart contracts, compile them, deploy them, connect them to a front end, and so on. So Solidity is basically a statistically typed scripting language where the processes, the data types, everything are verified at the compile time, not at the runtime. So these are just the highlights of what is Solidity. Now, again, you may think that is Solidity the only programming language with the help of which we can develop the smart contracts? No, it is not like that. There are many other programming languages like Viper, Go, even Python can be used. But Solidity is the most extensively used programming language because this was the first language. So let's move forward. So this was just a quick introduction to Solidity. Okay, so before we start doing our coding or writing our first Solidity program, we need to look at certain concepts in Solidity and then we can move forward. So we need to first understand what is the difference between memory and storage in Solidity. Okay, so there are two types of storage locations that can be used when you're writing your programs. Now, why do I need storage locations? Because obviously when I'm declaring a variable, I need to store that variable somewhere. So if I want to store anything, any variable, data type, so I have an option of either using memory or storage. So mostly when we'll write our smart contracts, we are going to use memory. Okay, so let's understand what is the difference between these two. So memory, it is used to hold the temporary values. Okay, so whenever you are storing any variable or a data type in memory, this would be a temporary storage, which means that the values which you store in that variable will be erased between external function calls. Okay, so within a function, if you're operating, the value of that variable would be intact, but as soon as the control goes away from that function, the values would be erased. So since it's a temporary place to store data, it is cheaper to use. Okay, so as when I say cheaper, it means that for every function we have to, when we execute every function, we have to pay a gas fees. So while developers write Solidity smart contracts, the main motive is write an efficient code which has less gas consumption or which follows gas optimization. So in such situations, using memory as a storage for your data types is a better option because it is cheaper. Coming to storage, so not necessarily that you would afford that all the values of variables can be erased between calls. So if in such situations, mostly the contract state variables reside in storage. So we are going to understand each and everything, like what are state variables, what are local variables, global variables, and so on. So whenever you are declaring contract state variables, they always reside in storage. What is the reason? The value of any variable that you declare as storage is persistent between function calls, which means the values do not get erased. So since the values are persistent, it is quite expensive to use. So if you just compare memory and storage, memory is cost effective, or you can say gas effective, whereas storage is expensive, but the values are stored permanently. So depending on what is the need or the requirement of an application and the data types of variables that you are creating, we can decide on whether we want to use memory or storage for a particular variable. Okay, so I hope this difference between memory and storage is clear. Any doubts up to this? Okay, students. So if at all you are finding something difficult or not able to understand, you can even put your query in the chat box if you need, or you can unmute and speak. Both ways, it's okay. Now moving forward to the Solidity smart contract layout. Okay, so we are now moving towards writing our first ever Solidity smart contract. So this is how the layout of a smart contract looks like. So the source file can contain contract definitions, including directives and pragma directives. So let's understand this very simple representation of first ever contract that you're writing. So your contract starts with the pragma directive, which gives the version of the compiler you are going to use to avoid breaking changes introduced on future versions. So this statement, you are going to write it in every of your smart contracts. So pragma, then is the name of the compiler, which is Solidity. You see an exponent symbol here, which means that this code can be run on version 0.4.18 or higher. Okay, so this exponent means any version this and any version higher to this smart contract could be compiled. Then you are going to start with the keyword contract and then you give a contract name. So you would just observe that it is very Okay, students, sorry. So I was having a network issue, so I got disconnected. So we'll continue. Yes, so we were discussing about the layout of Solidity smart contract. So you can observe that the Solidity smart contract looks very much like a C++ code. Starts with the Pragma version, which tells which version of Solidity we are going to use. Next is you start writing everything inside contract. So contract resembles what you write classes in C++. So you have to use the keyword contract followed by any user given name. I have given hello world and then the scope of the contract, that is opening and closing bracket. So this is just the layout. Let's move forward. So coming to general value types. So before we start writing our codes, we need to understand that how do we declare variables, how do we write functions, and then we can start writing our Solidity code. So with this very basic code that I have written in this PPT, we can understand how to declare variables, what are the different data types available. So as said, every Solidity smart contract starts with a pragma directive. So this particular contract can be compiled on Solidity version 0.4.18 or higher. I guess someone has unmuted. Please check your mics. Right. So let's look at how to write the contract. This is contract. The name of the contract I have given is value types. Then you start an opening and a closing bracket. Inside this, you have to write your entire contract code. So let's see how to declare variables. Different data types which are available with Solidity are uint, which is unsigned int, integer 256. Then is you can also write constants. So when you use uint, so when and where are you going to use unsigned integer? So whenever we are going to deal with currency values or some amount, we are going to use unsigned integer, because anyways, if I say 50 rupees, okay, so it will never have a sign like a positive or a negative. It's always a positive number. So no need to use a signed integer. We can use unsigned integer or a Unix timestamp. So we are going to understand what is the importance of timestamp variables in Solidity. Next is integer. So I have used int constant, which means that I am declaring a constant of type integer. I've given a variable name and thus set the value to a fixed value, which is 8. Just some random examples. Int 256. Int and int 256 both are one and the same thing. If you do not write 256, still int as a data type is of 256 bits. So both are allowed. This is explicit declaration that you are going to use 256 bits, and this is implicit. So here I am declaring one more constant, variable 2, and assigning certain value to it. Next, again, one more example of unsigned integer constant, that is version ID. I'm giving certain version to it. So whatever constant variables we used to declare in any other programming languages, we can use that variable instead of this value every time in my code. Then I can also declare variables like I've declared here B, C of type uint 8. So the number that you see with the data type is the size that it can hold. So uint 8 can hold 8 bits of data. Int 64 can hold 64 bits of data. Uint 48 can hold 248 bits of data. And then is the variable name. So the declaration is very simple. It's data type space variable name that you want to give. Next, where what the statement you see is int x is equals to int b. Okay. Now just observe that this statement is an example of typecasting. We used to do typecasting in C++ also. That typecasting means converting one type into another. So if you observe, B was of type uint, which was unsigned integer. Here I am converting it forcibly into into a signed integer and storing the value in x. So we can do that, that is typecasting, but we have to be very careful when we are typecasting the variables, because if you are typecasting a smaller size data type into a bigger size data type, you're not going to lose data. But for example, if you are having a float number and if you are typecasting it to an integer, this can result in loss of data. So while typecasting, we need to be very cautious whether the typecasting is leading to any data loss or not. Next data type which Solidity supports is bool. So bool is a Boolean data type. So in our code, we need certain occurrences where we need to check whether some value is true or false. Okay. So we can use the bool data type for that purpose. So bool is the data type, b is the variable name, is equals to true. I'm setting the value as. Coming next is the address data type. Now this is a very special data type which you will not find in any other programming languages you have studied earlier. Because as in case of blockchain, you have to deploy the smart contract onto the network. And to do that, you need an address, which is Ethereum's address. So this address is a special data type which holds a 20 byte, or you can say a 160-bit Ethereum address. Okay. So address is a special data type which can hold 20 byte of Ethereum address. Then you give access specifiers. Okay. So this access specifier you used to use in C++ like public, private, protected. So protected is not frequently used, but yes, public and private are frequently used. We know that if you declare a variable as public, the value is available throughout this contract and even from outside the contract also. So this owner is just the name of the variable that I have given. Next, we are going to look at the byte data type. So byte also has many variations in which I can use it, like byte, bytes 2 or bytes 32. So these bytes data types are available from 1, 2 or 3. Byte is same as bytes 1. Okay. So if I write bytes 1 or byte, it is one and the same thing. It can store 1 byte of data. Similarly, bytes 32 as well. Next, we also have string data types in Solidity, in which directly we can pass a string value. So how do you declare a string data type? String space variable name. This is a direct initialization. We can take user inputs also. So string n is equals to, in double quotes, some string which is hello. So we can, or we will need to deal with strings also in our smart contracts. So we need to remember that strings are stored in UTF-8 is a formatting, okay, in double quotes. With the formatting or an encoding mechanism which Solidity uses. So we all know that any high-level programming language writes text, human readable text, but those are not how the machine interprets it. Machine interprets it in the form of binaries, that is zeros and one. So UTF-8 is an encoding which converts this string into a binary representation. Okay. So this, up to now we have just looked at what are different data types available in Solidity which we can use. Next, we are going to go to user defined types. Okay. So there are two types of data types, that is primary and second is user defined data types. So under user defined data types, we are going to look at arrays, structures, like we used to do it in our any other programming language that you have studied before. So arrays, how do we write arrays in Solidity, how to write structures in Solidity, all these things we need to cover. And then only we can start with writing our own smart contracts for different use cases. So arrays, why do we use arrays? So whenever I want to store something in a sequential manner, or under one name I need to store n number of values, I can go with arrays. So arrays in Solidity can be of either fixed or a dynamic size. So here I've not written the entire code. It is just an image which shows different types of array declarations. Okay, so let's understand this. So here is a contract. The name of the contract is C, inside which I have written a function. Okay, how do you write a function? Function name, which is F, any argument that you want to pass, and the data type of that argument. So here function F, I am passing one argument which is length len, and the type of length is unsigned integer. Okay, inside this function I am declaring certain variables. So let's understand each and every variable declaration here. So the first variable name is of string type array, and the size is fixed, which is 5. Okay. Next, let's take an example of second declaration. The name of the variable I have given is dynamic array, just to resemble that it's a dynamic array. Why am I calling it as dynamic array? Because I haven't mentioned what is the size of this array. The square bracket is empty, which means that the size is not given at compile time. It will be decided at runtime. That's why it is called as a dynamic array. Whereas this one, that the first array that you have written, name, which is of string type, here you have declared the fixed size array of size 5. Now coming to allocating memories to array, we can follow the standard representation of dynamically allocating memory to an array. So here you can see uint memory A. Now, initially we have studied that either I can use memory or storage. I am using memory, which means that the value of this variable A would be deleted between different function calls, or it is a temporary storage. So I've declared a array of type uint. The name of the array is A, and new uint 7, which means I'm then dynamically allocating the array memory size of 7. Next, I'm declaring a bytes array. So bytes memory B is equals to new bytes len. Okay. So these are the different types of declarations we can use. So coming to the two arrays that I've declared right now, that is A and B, right? So A dot length is 7, which I have declared it here, and B dot length is what this function is accepting as an input, right? So either ways we can do it. Either we give it directly the size in the declaration, or we can take a user input and make that as the length of the array. Both the ways we can do it. Okay. Now we have this way of assigning the values to the variables, also directly giving the array name, which is A. To the position 6, I am storing the value 8. Okay. So this is very simple demonstration of declarations in array. We are going to do all kinds of stuffs like taking inputs into the array, user inputs, then performing different array operations, like whatever, like we have done maximum, minimum elements, sum of all the elements. So this is just the preliminary stage of understanding the different data types. Okay. So I won't go to the next topic, which is structures, but just we need to just discuss the difference between arrays and structure and the need of using both of them. So arrays basically we use when we want to group similar kinds of items together, whereas structures are custom defined. Whenever there's a need of grouping different data types together, we have to go with structures, not arrays, because array can group only similar types of elements. A structure can group dissimilar items also together. So we'll